So hello guys and welcome to my channels. Today again I am back with another important numericals and basic electrical engineering. And here on the screen you can see a circuit, and in this circuit we have to calculate the equivalent resistance. Here we have to calculate the equivalent resistance as well as the power dissipated in the 5 ohm resistor, means these 5 ohm resistors. So first, starting with the solution, we'll calculate the equivalent resistance. So in order to calculate the equivalent resistance, here you can see this is 1 ohm resistors and this will be in series with, and now again here these 2 ohm. Now these 3 and 4 are in series, so 3 plus 4 is going to give 7, and now this is 5 ohm resistor. So now this is 3 plus 4 7, so 2 ohm is parallel to this 7 ohm, and again 5 ohm resistor is again parallels, means these 3 are in parallels, and again these 6 will be in series with these combinations. So first we'll write here 1 plus, and here 2 is parallel to 3 plus 4 7, and again 7 is parallel to 5. So here I have written 2 parallel 3 plus 4 parallel 5, and again this in series, so plus 6. So here R equivalent will be 8.1864 ohms. So this is our equivalent resistance. Now here total current will be I equals to, here we have used 24 volt battery, so 24 upon this equivalent resistance, so 24 upon 8.1864 is going to give 2.9317 amperes. Now here, in order to calculate the power dissipated in 5 ohm resistors, here we need to understand the current division rules. So for that, here you can see this circuit, and here two resistors, here R1 and R2 are connected in parallels, and here this is the current flowing through this. Here the current supplied by the battery is I, and the current flowing through this resistor R1 is I1, and this R2 is I2. So here we can write I1 as V upon R1. So V is equals to I into R upon R1, and here R is the equivalent resistance of the combinations. So we can write I1 as I into, and here R1 is taken above, so 1 upon R1, again 1 upon R, 1 upon R. So here I1 will be 1 upon R1 upon 1 upon R1 plus 1 upon R2 into I. Since 1 upon R is the parallel combination, this R1 and R2, so 1 upon R1 plus 1 upon R2. So 1 upon R is going to give 1 upon R1 plus 1 upon R2. Now here if you calculate this, you will get I1 as I1 equals to I upon R1 plus R2 into R2. And here you can see 1 upon R1 means conductance, so this is written as G1. Similarly 1 upon R1 means G1, and 1 upon R2 means G2 here. So in terms of conductance, we have I1 as 1 I into G1 upon G1 plus G2. Similarly, the current flowing through this resistor R2, here we have assumed the current flowing through this resistor is I2. So I2 will be I into G2 upon G1 plus G2. So here, and also if R1, R2 and R3 are in parallel, suppose 3 resistors are in parallel here. So for that case, we can write I1 as V upon R1, and V is equals to IR upon R1, and here R is the equivalent resistance of the combinations. So I1 can be written as I into 1 upon R1, and again upon 1 upon R, since here R1 is taken above, and again here this R is taken below here. So 1 upon R, and here in the numerator part we have 1 upon R1. So I1 can be written as 1 upon R1, and 1 upon R means the parallel combination of these. Since R1, R2 and R3 are in parallel, so 1 upon R is going to give 1 upon R1 plus 1 upon R2 plus 1 upon R3 into I. So here if you solve this, you will get this value. Now in terms of conductance, we can write I1 as 1 upon R1 is going to give G1, and 1 upon R1 similarly G1, and 1 upon R2 is G2, 1 upon R3 is going to give G3 into I. So I2 will be G2 upon G1 plus G2 into G3 into I, and I3 will be G3 upon G1 plus G2 plus G3 into I. So this is our current divider rule. Now let's see the solutions. So here now using the current division rule, so current following through these 5 ohm resistors, since we are calculating the current following through these 5 ohm resistors, so for that we have I5 ohm will be conductance of these 5 ohm resistors into I upon this 5 ohm plus conductance of this 7 ohm plus conductance of this 4 ohm resistors, 2 ohm resistors. So G5 ohm plus G7 ohm plus G2 ohm conductance. So here G conductance of 5 ohm is going to be 1 upon 5 since G is equals to 1 upon R. So here, so for this it will be 1 upon 5 into, and I is calculated as 2.9317 ampere, so into 2.9317 upon again 1 upon 5 plus conductance of 7 ohm resistor is 1 upon 7. Similarly, conductance of 2 ohm resistor is 1 upon 2. So on solving we will get here 0.6957 ampere. Now we need to calculate the power dissipated in the 5 ohm resistor, means this 5 ohm resistors. So for that we have I 5 ohm means the current flowing through these 5 ohm resistors into the resistance of 5 ohm resistors. So here current following this 5 ohm resistor we have calculated 0.6957 ampere. So here we have 0.6957 ampere into R5 means this 5 ohm resistors into 5, and this is going to give 2.4197 watt, and so this is our required answer. So the power dissipated in 5 ohm resistor is going to give 2.4197 watt. Hope you enjoy the lectures. Thanks for watching, and please don't forget to subscribe to my channel. Thank you.